Yeah, thank you for having me. This is my third EmberConf, so I'm excited to finally be speaking here. I'm just going to dive right in. This is pixel by pixel visual regression testing in Ember. Yeah, I am Mike. I'm the co-founder and creator of a company named Percy. Percy is actually an open source Ember app. It's one of the few sort of like production web apps. You can go just like view all of our source and find all of our bugs and fix them for us if you want to. So yeah, check it out. You can sort of see how we do things in our Ember app. It's not Ember 3.0 yet, but we're very close. Yeah, so this talk sort of comes in 3 different sections that we'll go through. We're going to explore the problem space of visual testing in general. We're going to talk about visual diffs as a solution to that problem. And then we're going to talk about how we architected Ember Percy to sort of attack this problem as well. Jumping into the problem space. So the problem space goes something like this. There's quite a few tools and techniques for unit testing. Like, we all have a really good understanding of unit testing now, and like Ember's testing story is pretty fantastic, especially in comparison to everything else. And we build all of these systems. We can smoke test all the way. You can smoke test your deployments. You can write end-to-end tests. You can write integration tests. You can do really specific unit tests. We build these grand machines. This is Concourse CI, to like visualize our deployment pipelines. And we can release 100 times a day, right? But then how do you test something like this? So I don't actually even know what happened to this. This is a real bug that I hit like 4 years ago. Maybe the text is gone now, or like the text is the same color as the background, or something happened. And this was fixed by filing an issue from one of our customers. Or here's another example. This is a 404 page of an app I used to work on. This is how it's supposed to look. We made a change, and then I think it was like 4 weeks later, we found out from one of our customers that it looked like this. You all know exactly what happened in this one too, right? So we made a fix. We launched the fix. The fix looked like this because we didn't QA it on mobile. And then I went to pull sides for this like 6 months after this happened, and the page looked like this. So I reported it to my old team. So in the business, this is what we call a regression, right? And specifically, this is a form of visual regression. So usually what I would want to do in this situation, like take this one for example, is write a regression test for it, like write something so that this never happens to me again. So here is like an acceptance test for something similar to this. So it's just a simple, describe something, it creates a new project, we visit a page, we fill in some information, we click a button, and then we have a set of expectations about what happens as part of that test. But there's a problem here in terms of like a regression for that particular change, right? This thing still passes. The button still technically works. It's just visually wrong, right? So what am I supposed to do here to make this a regression test for this particular bug? Am I supposed to like assert that there's some class on this thing, or like it has a CSS computed style, or that maybe the color of the thing is equal to something? And I've seen companies do this. What I'm about to show you is totally real. This is an example of what test suites end up looking like if you sort of go down this trail without like some boundaries around it. So this is like, I've sort of scrubbed this so you can't figure out who it is. But like, this is code that I used to have to work with. And if you sort of squint and look at this, there's some stuff in here like expect that the post dismiss button does not exist on the page. So you're writing expectations for things that like don't exist, which could be everything, right? And this is not even the whole test, right? The whole test actually looked like this. And maybe if this is like a critical part of your infrastructure that you really need this level of coverage, but go rename this component. What are you gonna have to do to maintain this test? It's a little bit insane. And then there was examples of this all over the code base because we created like a culture of testing this way, right? So there's just got to be a better way. So how do we handle this today in sort of like launching product changes every day anyway? Usually this is through QA, right? QA is very necessary. It's something we all do. We're not going to stop doing it anytime soon. But it's very manual, it's very expensive, and it's very error prone, right? It's a big leaky process, which is why things get through to production all the time. And it's just impossible to catch everything, especially if you're doing like very manual QA. It's, even in some of the examples I'm showing you, there's like thousands of possible page states and permutations of these page states, and the product is constantly changing and updating and getting new features, so you have to keep up with that as well. And you're also relying on people's memory to remember what the page looked like before, so you're always going to miss stuff anyway because we're just not good at these things. So the problem fundamentally, I like boiling it down to this, is that pixels are changing, but we only test what's underneath those pixels, right? We're only testing the abstractions underneath the pixels, not the pixels themselves. And if you take that one step further, then it's like even with all of our current testing strategies and methodologies, we still lack visual confidence in our deploys. So how can we know what pixels are changing, and how can we get this visual confidence in the changes that we're making? So an answer to that is this thing called visual diffs. Who here has heard of visual diffs or perceptual diffs? Okay, handful of people. So they're called many different things. They're called like perceptual diffs or P diffs, visual diffs, CSS diffs. I've heard them called like UI diffs. And they go something like this. They're pretty straightforward overall. So given two images, what is the difference between these two images? Like computationally, what is the delta between these two images? And that could be something like this. So all the red pixels you see here are the pixels that have changed between these two images, right? And it catches stuff like, the drop shadow got extended down, like things you may not think to actually call out if you're saying what are the differences between these two images. And I'm going to show you a couple of examples of visual diffs. So if you take these two side by side, you could probably, if I gave you a few seconds, you could figure out all the diffs that are there. But if I just show you the visual diff, you can immediately see what's happening in these two things. You can see the big bars change, flip back and forth, the danger button's gone, the link is gone. And then something you may not catch as easily, like the N in thumbnails in the bottom has become capitalized. And you can also see with confidence that nothing in this like nasty table has changed, right? So it sort of gives you this quick reference point of like, what do I need to care about on this page? What's like visually changed? Here's another example from a real production app. I love this one because this is an example of a backend change manifesting as a front-end failure. So this is like a Rails app where the Rails form object got into some weird state that like caused, which you see here from the visual diff, the like, do you agree to the terms of use checkbox is just gone. So you probably can't submit this form anymore. It probably will just error anyway, but that's actually gone as part of this change. So you can see how like, because all of the systems are sort of very intertwined and very interleaved in a lot of ways, you might have back-end changes that if your back-end and front-end are coupled in some way that might manifest as a front-end failure or as a front-end like change. And another sort of example of visual diffs that I like calling out is the fact that a 0 pixel change pdiff is a really important signal for you because it tells you with confidence that that page hasn't changed. So my favorite set of like changes to look at is 999 visual diffs didn't have any changes and 1 did, right? Because then you don't have to go look at those 999 changes. They're just what they were before. They're sort of previously approved. So this is a really strong signal to sort of get a sense of what you actually need to care about in terms of what's changing in your app. So how do we make visual diffs? It's very easy. So if you have the ImageMagick library installed, you can use the ImageMagick command line tool called compare. Give it an old image, give it a new image, and then give it an output image, diff.png, and it'll generate a visual diff for you. You can pass a whole bunch of different options to this. You can like pass in fuzz factors and like color blending and thresholds, and you can get like different outputs of transparency and stuff. And it's a really flexible way to sort of make these visual diffs. So just a handful of like use cases for visual diffs. You can use these to catch visual regressions. That's the big one, right? Those tests that we were writing before, you don't have to write them anymore. Just look at the visual diff of the things that have changed. Who here is afraid to delete CSS? Yeah, okay, basically everyone. It's terrifying, right? You have no idea where that CSS is used. We're smarter about this in the Ember world, right, where we can like componentize our CSS and have it like next to the thing, but it's still scary, and so we just don't do it, and then you end up with like a huge amount of CSS in your app. So add visual diffs to your top 50 pages, and then go delete some CSS and see what happens. If nothing changes, you're probably pretty fine to like launch that change, right? Making dependency upgrades is safe. I love a sort of like combination of like something like Greenkeeper IO and Percy doing visual diffs, because then you get this like automatic PR that both upgraded your dependencies and then also you know that no visual changes were impacted, and it just goes through and no human ever even saw it. So there's like a cool sort of coupling there. And then testing visualizations, I think, is a really important use case for this kind of stuff. I'm not like a D3 expert by any means, but you can write tests for D3, but it's usually just testing like inputs and outputs into your visualizations. But you don't actually care about that. You just care about what it looks like, right? And so if you can just test the like final output of the visualization and know when it changes, that's a pretty effective test for what you're going for in that world. So that's it. Visual diffs. We're done. Why aren't we all doing this today? And the problem, of course, is like with anything in technology, that it just comes with a whole host of more problems. And so we're going to talk through those. So the problems there, I like talking about them in 3 different categories: the sort of tooling and workflows, performance, and non-deterministic rendering. And we'll go through some examples for these. So the tooling and workflows is like sort of just the first questions that hit your brain, like where do we store these images? What's like the golden master baseline of them? You know, how are we approving changes to them? Are we storing them in our repositories? Are we like generating them from, you know, developer machines, et cetera? There's just a whole bunch of like tooling questions around this particular thing. And then performance, I actually think, is the biggest cause, the biggest blocker to sort of doing this in the industry right now. And this is like a huge part of this, because I have an example that sort of talks through the timing of this. We have some visual diffs in Percy that are, you know, the pages themselves are 30,000, 40,000, 50,000 pixels high. And even normal pages can take 10 to 20 seconds to get a full page lossless PNG generated from Chrome Headless or whatever you're using to generate the screenshots. So the render time for these can just add up really quickly. So if you had 100 UI states of this and you were taking 100 screenshots in your test suite, for example, and we were like uploading those and storing them somewhere, that could be 2,000 seconds. You know, it could be that you're adding 30 minutes to your test suite, which just no one wants to do, right? Like our test suites are already too slow. So I think that this is one of the biggest blockers of being able to do this right now. And something that we've spent a lot of time at Percy trying to go through, which we'll go through in a minute, how we handle that. And then the non-deterministic rendering, and I have a bunch of examples for this. So the simple first one you can think of is like animations. Like how do we handle animations on the page? Like if you take a visual diff of a page that has an animation on it, which visual diff are you going to get? You might get this diff, or you might get this diff, or you might get this diff. You know, it depends on the frame of the animation that you're actually visually diffing. And that's just not useful at all, right? Like this is a pure CSS animation here on the left. I can instantly see as a human, like, yeah, that looks great. I'm ready to ship that. That's fine. But the visual diff does sort of like lose the signal in this particular case. So what we do in Percy, and you can see this on our blog too, is we inject some CSS into the page to like aggressively turn off CSS animations and turn off like animated GIFs and any other things that we can sort of control for to make sure that it just says like, you know, no visual diffs detected between these two things. Dynamic data is a big issue. So we've only tested the abstractions underneath. We haven't tested the pixels yet. So once you start testing the pixels, you have to care about the fact that you've used fake data all over your test suite and it's randomly generated. So Ember actually has a lot of good mechanisms to help fix this really fast. So sort of Ember pro tip really fast here. You can use faker.seed, give it a random number, or like a stable number, not a random number, and it will generate the same seeded data every time through your test suite. So all of a sudden, your fake data is now stable, even though it's still fake. Or also, our friends over at Ticketfly have made a thing called Ember mock date shim, which you use these sort of freeze date at and unfreeze date at helpers, and then all of a sudden all the dates that are generated in your test suites are all the same. So if you're using like moment.js will all of a sudden have the same stable date. And all of a sudden your visual diffs go from pretty noisy to very stable very quickly with these two tricks. And then sort of a bunch of things that are just much harder to control for. So like if you're using an old test browser, this is a Rails example. So like if you're using Capybara WebKit, Capybara WebKit is a fork of WebKit from PhantomJS is also was a fork of WebKit from like 7-8 years ago. It was like from like Chrome 14. So it just doesn't, they don't render the modern web. We're moving nicely into like using Chrome headless, you're using Chrome headless and like a modern browsers for these things now. So this is becoming less and less of an issue. But you know, you can see here this like doesn't support web fonts, doesn't know what a border image is. There's a bunch of other things happening here. Or like PhantomJS 1.9 before the recent 2.1 and then before just going kabosh. It has like doesn't support background images, wasn't floating things correctly. And then you have to think about like what happens when you're going through browser upgrade cycles because you want to keep this stuff modern anyway. So there's a whole sort of like maintenance part of this question as well. And then some stuff we've hit in Percy that we're just like, what? Like what happened on this one? So for example, once we got a customer who said, hey, sometimes this button's hover state is triggered and sometimes it's not. I was like, what could that possibly be? So I made this thing and sent it up to Percy 50 times and just rendered it a bunch of times. And each div just responds to hover active and becomes green. And every once in a while, there'd be a green square there. And I learned that even in XVFB, like the Linux virtual frame buffing window environment, that's like the lowest level Linux windowing environment you can have, still has a cursor. And the cursor's in the middle of the screen. And sometimes, depending on what window's in front, it would trigger a hover state. So guess how we fix that? Move the cursor to 0, 0. Yep. Subpixel anti-aliasing. You know, this is if you render a GPU rendered gradient, GPUs don't actually guarantee that division happens the same across different GPU chips or different like compilation flags for the software that you're using. So if like you render a GPU rendered gradient on one machine and then you render it on another machine, they probably will not look pixel by pixel the same. Or if like fonts get upgraded on the machine, they might be anti-aliased differently. Or if there happens to be a performance load on the machine at the time, the browser may make trade-offs to actually like render things faster and less accurate, right? So there's a bunch of things that are just really hard to control for with these things. So let's go back to our questions, like how do we know what pixels are changing and how can we get confidence in our changes overall? And I started thinking about this in terms of like, well, how do we do this with our code right now? Like, how are we getting confidence in our code processes? And it seems kind of obvious in retrospect, but you know, this is kind of like code reviews. You get a lot of benefit out of code reviews that you're not getting from like a static analysis tool like a linter or something else, right? Your friends on your team will say like, oh, you know, we don't need that system anymore. We have this other system here, or like here's a different architecture, or they'll spot bugs that you didn't mean to introduce. Like we get a lot of benefits from this code review cycle that we have on our teams. So is there a way that we could do that with these kind of visual reviews? Could we have like a real visual review cycle as part of our code reviews? And how can we make these visual reviews as easy as code reviews? So asking that question started making me reframe this in a bunch of different ways, because you have to care about like the tooling and workflows. You have to fix the performance problems. It has to be as fast as like the rest of your environment. It has to be as fast as your CI suite. It can't really be slower than that. Otherwise, you're introducing more pain, not actually fixing the problems. So there's this whole sort of like review angle as well. And so moving from visual diffs now into like the architecture for EmberPercy, I'm going to show you how we've sort of tried to tackle these problems and then dig into how EmberPercy actually works underneath and how it sends up stuff to Percy, and then what we're actually doing on the Percy side of the architecture as well. So very quick demo, EmberPercy, 2 minutes. So you just Ember install EmberPercy. Then given any of your like acceptance or component tests that you have, you just import the helper up at the top, and then you can just drop a line into any of the places in your test suite where you want this kind of visual coverage. So you can like visit a page, fill in, click, and then after your expectations say, okay, now snapshot this page. You can do this across any component or acceptance test suites that you'd like. And then you just sort of configure your CI environment to be able to talk to Percy, run your tests like normal, and that's kind of it. So then what we do with that on our side is you go through and you create your pull request like you normally would. And then we notate the PR and we say, hey, even though you've had 2,000 tests that have just passed, like functionally everything's ready to go in your application, there are 21 visual changes you might want to look at as part of this change. So then you click on details and sort of jump to the Percy view for this thing. And what we do is show you a side-by-side comparison of what has changed in your app. So what's on left is in master, what's on right is what's about to go out as part of this PR, and there's the visual diff. And you can see just by like clicking the visual diff here on the right, like this is what's underneath, I meant to change only this blue button up here in the top right, but I'm actually affecting a whole bunch of things in this page that I didn't anticipate. And we support being able to do this across like different mobile and responsive widths as well. So you can sort of configure Ember Percy just in your normal config environment JS, which breakpoint widths you actually care about by default. And then we render all the pages at those different widths. And then we just show you all of the diffs side by side, so you can sort of go through and see like, oh, I'm going to break the homepage call to action button, and I didn't know that because I just didn't look at the homepage as part of this change. This is actually the Travis CI page, or app, which is also an open source Ember app you can go look at. And we can sort of support all of the different types of states that you can get your Ember test suite into. So like, this is a pretty complex UI state where you're like logged in and like the drop-down's been clicked and like a bunch of other things have happened on this page. And we can tell you with confidence, yeah, something has changed in like that drop-down state for that particular thing, before you actually have shipped it. And then if you're not happy with these changes, you just push up a new change, and the Percy build runs again, and we generate all these diffs, and you can sort of iterate through the process. And then once you're happy, like say you're happy with these changes, all you have to do is sort of click the approve button in the top right, and that marks all the changes as approved. And what we do after that is mark the PR status as green. So that's when we talk about like a visual review cycle, that's what I'm talking about. Like go back and forth all the way through this every time you're in a PR, not like on some staging server, not in a QA environment later. Just do this as part of our normal development, day-to-day development workflows. So what are we actually doing underneath this thing? Like that's kind of magical. Like what are you actually doing? Well, thankfully, we've been able to get rid of this kind of stuff, right? Like we're not writing a bunch of expectations about what those things have changed. So what we do underneath this is, you may think that we're sending up images to Percy as part of those snapshots, but I say that with like a lot of question marks here because that would come along with all of those same performance problems and rendering difficulties that we talked about before. So what we actually do here is we send up DOM snapshots. So we just take a capture of the HTML along with your like development assets, ship that up to Percy, and then we reconstruct the state of your page on our side in a custom rendering environment that's specifically been built for visual testing, and then render and do these visual diffs. And if you think about that's a great way to sort of like represent the page, because the lossless version of a page is actually like most efficient encoding format for a page is just the DOM of it. It's not like an image of the page or like a video of the page. It's just the DOM. It's the state of the page that you actually created in your test suite. So we ship that up to us, and that's just a simple like, here's some HTML kind of call. And then we actually go further than that and just sort of very deep in the weeds for a second. We SHA-256 fingerprint all of the assets and DOM snapshots that we upload. So effectively, we never upload anything twice. So the first run might be kind of slow, but then after that, you sort of are only shipping up the differences in your assets to us, and then we can sort of handle the performance of that and the rendering of that on our side. And then to give you a little sense of like what we're doing underneath, as your tests run in your sort of CI environment, we extract a bunch of metadata about like, what build is this for, and do you have like a parallelized build environment, that kind of thing. Then we talk to GitHub and set commit statuses. And then sort of in the box that is Percy underneath, we have a bunch of storage and a sort of a Redis-based scheduler that does the sort of job scheduling. Because the biggest performance win that we can make with this kind of architecture is that we can parallelize this. Completely out of band of your CI suite, totally asynchronously. You just send us DOM snapshots, and then we dedicate multiple rendering rendering machines to be able to run these browsers and do the diffs, so you can actually sort of tune it as fast as you want it to go and make it really part of your CI suite. So that sort of DOM snapshotting architecture has really helped us get to be able to solve the points that I've been going through of like what were the problems we hit along this. So yeah, so we integrate into like the GitHub PR workflows. Performance becomes as fast as you want, and then like deterministic rendering becomes like a concern of our team, right? That we have to spend a bunch of time like making this environment be right and giving you the tools to be able to control it when it's not. And this is working right now. We've rendered almost 50 million visual diffs in Percy, which means we've opened Chrome and Firefox like 50 million times and taken 50 million visual diffs. So it's been great to see this sort of architecture validated in that way and to make visual diffs useful. So that's it. I just want to leave you with the fact that visual testing is possible. It's a thing we can do now. It's as much about like the philosophy of what's going into it as much as it is about the tooling of it. And it requires like a team adoption of this kind of workflow in the same way that you sort of like, you dig through code reviews and like you have your own processes and like ideas about that. Visual testing is very much the same thing. And it should just feel like an iterative code review process. We should all have full confidence in our deploys going forward, right? Like this, I feel like this is one of the last steps of the CI/CD pipeline that hasn't been automated. Is, you know, you can have all of these tools and techniques, and then you get to the end, and if you move a CSS file, you still have to go look at it, which is kind of ridiculous, right? So we should just be automating that fully anyway, so you can have full confidence in your CD pipeline. And then specifically with Ember, you want to make sure to like start with breadth of visual coverage over depth of visual coverage. So don't go to like one component and add like 25 different tests for that one component, and then all of a sudden you realize you haven't tested anywhere else in your app, right? Go add like one test to every acceptance test, and then all of a sudden you have a really nice broad coverage of your application's changes, and you can sort of tune what visual coverage you get over time as visual regressions come up, or as you determine like this is a critical part of our stack. We really need to make sure to be testing these pages. And then you sort of massage your test suite to prefer this deterministic data and freeze time versus what we're doing right now, which is just generate random data and let the time be, you know, now. So there's some really easy things you can use in Ember to make that stuff really easy. That's it. Thank you very much. Oh, gotcha. OK. Yeah, so the question is, can we support like Bitbucket and other private hosting for source code? We are in beta with a GitHub Enterprise installation, and then we're going to be working on like GitLab and Bitbucket next. So coming soon. Sorry, the question was, we mentioned that a lot of this is open source. Is all of it open source? And no, it's not all open source. All of the SDKs are open source. Our front end is open source. But then like the API and the back end and all the rendering environment stuff is the thing that we build and maintain. Cool. Thank you very much.